Hi, my name is David Ruiz. This is my project presentation for System Dynamics and Controls with Professor Hassan, and I'm in section 063. My project was on the inverse pendulum. The inverse pendulum is a staple of System Dynamics and Controls as it showcases an unstable system in need of system controls. The problem itself is a classic problem, and the great thing about it is that it has multiple solutions that all depend on the person that's working on it. The idea behind the inverse pendulum goes back centuries and has been solved different ways since then. While the inverse pendulum itself has no real use in the real world, being able to balance the inverse pendulum helps create solutions to other problems and other systems that are used. An example of this could be a Segway. A Segway is similar to the inverse pendulum in that if not properly balanced, it could lean too far forward and injure a person, or even too far back, which would also result in injury. The same type of balancing controls and systems were used in a Segway and countless other systems that need balancing, and it's something that could be used in future projects as well. The idea itself is very simple. It's just to try and balance an inverse pendulum. With no controls or system behind it, an inverse pendulum will immediately fall one way or another. Attempting to build a system that will keep it steadily in the middle is a good challenge for any engineer. The system requires a precise set of formulas, coding, and understanding of systems to really fix. The programming has to be able to tell the system to correct any movement in either direction. What makes this challenging is that it has to be an exact amount of correction. Any extra force will swing the pendulum too far in one direction, and once it tries to correct itself, it'll fall towards the other direction. That's where the knowledge of system dynamics and controls comes into play. You can build a system of equations and transfer functions to calculate at least a very close estimate to how much the exact correction should be. While it's not 100% accurate, the estimations give you a very good starting point to begin to guess and check what the exact number should be. Without the knowledge of system dynamics and controls, one could guess and check until they arrived at the correct value, but that would take an incredibly long time as you wouldn't even know where to start. The inverse pendulum was a simple yet complicated problem that I really enjoyed studying, and I enjoyed seeing the different ways the problem could be solved and how it incorporated all the parts of system dynamics and controls we had learned so far. I think it's something that could be applied to many projects in the future, and I thoroughly enjoyed researching it. Thank you for your time. This was my presentation.